November 19th. NASA finally spoke about 3I Atlas. What they revealed changed nothing. What they ignored changed everything. 12 space missions tracked this visitor: Mars Reconnaissance Orbiter, Hubble, James Webb, Maven, Lucy, Psyche, SOHO, Stereo, Punch satellites. Billions of dollars deployed across the solar system. Months of anticipation building worldwide. The scientific community expected breakthrough discoveries about the third interstellar object ever detected. Instead, they received a blurred sphere of light. NASA presented this as their flagship result. The high-rise camera aboard Mars Reconnaissance Orbiter captured it October 2nd from 30 million kilometers. Spatial resolution 30 kilometers per pixel. But spacecraft jitter during the 3.2-second exposure smeared light across the frame. The brightest region spans roughly 20 kilometers. That measures mostly coma material, not solid nucleus. Dust and gas and ionized particles obscure everything beneath. It resembled a foggy street lamp more than scientific revelation. Officials maintained consistent messaging throughout the broadcast. This object behaves like a comet. It sheds gas and dust. Gravitational forces govern trajectory. Natural origin. Interstellar source. Nothing unusual requires explanation. The narrative felt rehearsed. Questions received careful, scripted responses. No speculation allowed. Just confident declarations that everything fit understood physics. But something far stranger lurked beneath that surface. Dr. Avi Loeb from Harvard University examined the same data differently. The mass measurement alone should have dominated discussion. This visitor contains 1 million times more material than one Oumuamua. It holds 1,000 times the mass of 2 Borisov. Those numbers destroy statistical expectations completely. Think about what that means. Interstellar space contains limited drifting matter. Given that scarcity, astronomers should have found 1 million small objects before discovering one this massive. They should have detected 1,000 medium-sized visitors first. Instead, the largest interstellar object arrived before its smaller siblings. Random chance makes that extraordinarily improbable. The trajectory defied expectations even more dramatically. This path aligned remarkably close to the plane where planets orbit. That convenient positioning allowed multiple NASA observatories easy targeting. How convenient! Statistical analysis reveals such alignment occurs roughly 100,000 times less frequently than random three-dimensional trajectories. 100,000 times less likely. Either impossible cosmic luck smiled on space agencies, or something else shaped this approach. The ancient Greeks understood deceptive appearances. The Trojan horse seemed harmless to sentries guarding Troy. Surface characteristics masked true nature completely. We should not judge cosmic visitors by outer layers alone. Any object traveling through interstellar space for millions of years accumulates surface deposits naturally. Those sublimate under solar radiation exactly like natural volatiles. What lies beneath remains unknown. James Webb observed 3I Atlas on August 6th. Hubble captured images July 21st. Both revealed carbon dioxide dominating coma composition. Water ice mixed throughout. Standard cometary volatiles on the surface. But surface composition proves nothing about internal structure or ultimate origin. Then, observations started contradicting each other impossibly. Lucy spacecraft photographed from 240 million miles on September 16th. The tail extended, clearly visible, but material moved sunward, toward the star instead of streaming away. Solar radiation should push particles outward. Every comet in history follows this pattern. This tail pointed inward. Punch satellites captured even stranger contradictions through September and October. Some observations showed material pushing sunward. Others captured traditional anti-solar tails streaming outward. The same object, the same time frame. Opposite directions. NASA's briefing mentioned none of this. Mars appeared in one punch frame as 3I Atlas, passed close on October 3rd. The red planet manifested as a pixelated white blob. Meanwhile, the much smaller, fainter 3I Atlas displayed sharper, better-defined features. The apparent magnitude of Mars far exceeds this visitor. Yet the comet looked clearer than the planet in identical observations. Nobody explained that discrepancy. MAVEN provided ultraviolet observations detecting hydrogen emissions. The bright core measured 33,000 miles across. Dense coma material. Lower density hydrogen spreading beyond. Standard measurements. Standard interpretations. But one critical element remained absent from all discussion. Plasma. Everyone mentions gas and dust constantly. Sublimation, outgassing, photometric calculations. Yet electromagnetic processes govern everything observable. Solar radiation strips electrons, creating photoionization. Solar wind transfers charge through collisions. Free electrons knock more electrons loose, generating cascading ionization. Dust grains acquire electrical charges. Those charges create magnetic fields. Electric field structures form. Electromagnetic forces shape every emission pattern and particle trajectory. Why does nobody discuss this openly? Plasma physics explains what simple gas and dust models cannot. Electromagnetic confinement produces collimation. Charge separation generates directed flows. Magnetic structures channel particles along specific vectors. These processes create phenomena that mimic or mask other mechanisms entirely. Understanding plasma behavior proves essential for interpreting observations. Yet, mainstream discussion avoids the topic almost completely. The object reached perihelion October 29th. Closest approach to our Sunday peak solar heating. Maximum sublimation rates. Then, it moved outward past solar glare into observable sky. What emerged shocked experienced observers. Thank you for being with us. Please subscribe, share, and like. Amateur astronomers captured images beginning November 8th using accessible ground equipment. Those photographs revealed structures invisible in earlier NASA observations. Tightly collimated jets extended from the central region. Not diffuse outgassing, focused beams. One jet aimed directly sunward. Another streamed anti-solar. Additional jets spread perpendicular to that axis. These structures reached distances approaching 1 million kilometers, while maintaining narrow, focused geometry. Natural ice pockets, heated by sunlight, produce diffuse emission clouds. Irregular surfaces create scattered particle flows. Focused collimated jets, spanning 1 million kilometers, require specific conditions. Geometric confinement. Directional mechanisms. Something beyond random sublimation. 5 distinct jets appeared in November 8th imagery. The configuration evolved by November 16th, showing changed intensity patterns. Rotation period measures 16 hours. Yet jet orientations remained remarkably stable despite that tumbling motion. Emission appeared linked to fixed features rather than random outgassing that should smear across rotation. This stability demands explanation. Large telescopes will characterize these jets in coming weeks. Hubble and Webb can measure exact composition through spectroscopy. Velocity profiles indicate ejection speeds. Mass loss rates calculate from brightness and emission. Temperature distributions map along jet lengths. Those measurements will reveal whether natural processes or other mechanisms drive the emission. The distinction matters profoundly. Natural cometary activity follows predictable patterns. Solar heating creates specific temperature gradients. Ice sublimation produces characteristic velocity distributions matching vapor pressure equations. Typical speeds reach hundreds of meters per second. Composition ratios match formation environment chemistry. Everything follows thermodynamic laws. Technological systems generate entirely different signatures, higher temperatures from energy release, directed velocities potentially reaching kilometers per second, unusual composition ratios not matching natural ice chemistry, geometric collimation from nozzle structures, or electromagnetic confinement, temporal stability, independent of rotation, controlled activation patterns. Careful measurement discriminates between these possibilities. Evidence decides, not assumptions, not comfortable narratives. Observable data determines truth. December 19th approaches rapidly. On that date, 3I Atlas makes closest approach to Earth. Distance drops enabling enhanced observations from ground facilities worldwide. Major observatories scheduled intensive campaigns, spectroscopic monitoring, high-resolution imaging, polarimetry, radio observations. Amateur astronomers globally will track this visitor through our neighborhood. This represents final opportunity to gather comprehensive data before the object recedes into outer solar system and eventually back to interstellar space beyond observation capability. What will those critical observations reveal? 12 documented anomalies remain without explanation. Mass exceeding previous visitors by factors of thousands to millions. Trajectory alignment defying probability by factors near 100,000. Contradictory tail orientations in simultaneous observations. Million-kilometer collimated jets stable against rotation. Plasma environment receiving minimal analysis despite governing observable phenomena. Rapid brightness variations inconsistent with simple rotation. Unusual spectroscopic features requiring exotic models. Trajectory perturbations potentially indicating non-gravitational forces. NASA maintained unwavering messaging. Natural comet. Interstellar origin. Expected behavior. No unusual features. Standard physics explains everything. That narrative satisfied few researchers examining actual datasets. Science advances through anomalies, not confirmations. Unexpected results expose gaps in understanding. They point toward overlooked physics, new phenomena, expanded frameworks. Dismissing contradictions halts discovery completely. Defending comfortable paradigms against contrary evidence serves institutional interests, not scientific truth. The evidence deserves thorough analysis, not premature declarations, not dismissive reassurance. Genuine investigation of what makes this visitor unusual. Hubble already captured decades of cometary observations. James Webb brought unprecedented infrared capabilities. Ground telescopes improved dramatically with adaptive optics and large apertures. We possess better tools than ever before. The December 19th close approach provides ideal geometry. Northern Hemisphere observers get excellent viewing angles. Southern facilities contribute complementary coverage. Space telescopes add wavelengths inaccessible from ground. Every instrument brings unique capabilities to comprehensive characterization. Spectroscopy reveals composition through emission line identification. Carbon monoxide appears at specific infrared wavelengths. Water shows characteristic bands. Carbon dioxide displays unique signatures. Methane contributes if present. Ammonia adds distinct features. Each molecule leaves fingerprints across electromagnetic spectrum. Comparing relative abundances constrains formation conditions and thermal history. Imaging tracks morphology evolution. Coma size changes with heliocentric distance, following sublimation models. Jet structures rotate with nucleus revealing surface feature distribution. Disconnection events from solar-wind interactions. Fragmentation if structural integrity fails. Every change provides clues about internal composition and mechanical properties. Photometry measures brightness variations. Rotation periods emerge from periodic changes. Tumbling motions show complex spin states. Outburst events indicate sudden activity increases. Fading patterns reveal dust production rates declining with solar distance. All this data constrains physical models. Polarimetry adds information about particle properties. Dust grain sizes affect polarization signatures. Composition influences wavelength dependence. Coma optical depth modifies patterns. These measurements complement spectroscopy and photometry. Radio observations potentially detect unexpected emission. Some molecules radiate in radio spectrum. Radar returns, if achievable, measure nucleus size and shape directly. Surface roughness affects reflection properties. Rotation becomes immediately obvious in radar data. Range and velocity measurements refine orbit dramatically. The December 19th window lasts several weeks total. Pre-approach observations establish baseline. Close approach maximizes signal. Post-approach tracks evolution. International collaboration ensures continuous coverage despite Earth rotation. Northern and southern facilities alternate. Space telescopes fill gaps. Weather affects ground observations, but multiple sites provide backup. Data will accumulate rapidly during that critical period. Analysis takes longer than acquisition. Spectroscopic reduction requires careful calibration. Imaging processing removes artifacts. Photometric analysis corrects atmospheric extinction. Polarimetry demands precision measurements. Radio data processing extracts signals from noise. Every dataset needs systematic treatment before scientific interpretation. Results will emerge gradually through late December and January. Early findings appear in telegrams and circulars. Detailed analysis fills journal articles over subsequent months. Comprehensive understanding develops slowly as multiple lines of evidence converge or conflict. Surprises often hide in careful examination long after initial excitement fades. What will we learn? Perhaps composition measurements reveal exotic ices impossible in solar system formation. Perhaps jet velocities exceed escape velocity, indicating directed propulsion. Perhaps polarimetry shows artificial materials. Perhaps radio detects technological transmission. Perhaps everything fits natural models perfectly and anomalies resolve through better understanding. Perhaps mysteries deepen instead of resolving. The object carries information from interstellar space, from formation regions light years distant, from processes we have never sampled directly. Whether natural or artificial, it represents something beyond our previous experience. Something requiring careful study rather than hasty categorization. December 19th approaches. Thank you for being with us. Please subscribe, share, and like. The universe rarely provides convenient answers. More often, it presents deeper questions. 3. Atlas traveled millions of years to reach our solar system. It will pass through in months, then disappear forever. This brief window offers unique opportunity to study interstellar material directly, to test theories against reality, to discover whether our models capture truth or merely reflect limited experience. What secrets will our mysterious visitor reveal before departing back into cosmic darkness?